For this final video of Chapter 2, I'm going to discuss the concept of nomenclature, which is just a fancy word for naming. So I'm going to discuss how to name several different types of compounds. We're going to talk about ionic compounds, covalent compounds, binary acids, and oxy acids. And I'll explain what binary and oxy acids are and what the difference is between them. Okay, so let's start with ionic compounds. So we'll use NaCl as our first example. So when you're naming an ionic compound, remember, it's going to be a metal bonded with a nonmetal. The metal always comes first in the formula. So to start, you always just name the metal. So here, we can start with sodium. Then you can also name the root of the nonmetal and give it an IDE suffix. This is chlorine. The root of that is just chlor. So we say CHLOR, and then give it an IDE ending. So it becomes chloride. And that's actually it. Now, if your metal is a main group metal, like sodium is, for instance, you're done. That's all you have to do. If you have a transition metal, then you have to do one more step. So let's say, for instance, we have Fe2O3. We can start the exact same way. We start by naming the metal, iron, and we can name the root of the nonmetal with an IDE suffix, although I'm going to leave a little space in between these now. So, why did I leave the space? If you recall, I said transition metals are unique, well, not unique, but at least different from main group metals in the sense that they can have multiple charge states. And the charge state of that metal can drastically alter its properties. So, you need to know what charge of your metal you have if it's a transition metal. If it's a main group metal, it can only have one charge, so you don't have to worry about identifying it. So if you have a transition metal, in between these two words, you need to put in parentheses Roman numerals that indicate whatever the charge is. So we have to figure out the charge of iron here. We know oxygen is going to be -2, right? And there's 3 of them. So 3 oxygens, all with a -2 charge. That gives you a total negative charge of -6. Right? We have 2 iron ions. And if the 2 iron ions have to add up to... Okay, so if we have a total of -6 charge, that means that to cancel it out, to get an electrically neutral molecule, the iron has to add up to +6. And if we have 2 iron ions, that means that the charge of iron has to be +3. So this is going to be iron 3. So in parentheses, ooh, my marker's kind of going a little bit. I might switch to orange here in a second. We have iron 3 oxide. And now you're done. The one exception to these rules is if you have a polyatomic ion in place of either the metal or the nonmetal. So let's say we have here sodium nitrate. Well, I just said the word. Basically here, you just say the metal once again, and you just give the name of the polyatomic. You don't change the ending of the polyatomic. So this would just be sodium nitrate. With covalent molecules. So if you recall, covalent molecules are when you have all nonmetals bonded together. So let's start, as an example, with PCl5. So you're actually going to start the same way. So obviously we don't have a metal first here, but you're just going to name the first element as if it was an ionic compound. So we start by saying phosphorus. I'm going to leave a little space, and then we can actually just name the root of the second element with an IDE suffix. Once again, just like if it was an ionic compound. It might not have been enough of the space, but that's good enough. So, why did I leave a space? here is where covalent compounds differ in naming from ionic compounds. With covalent compounds, you have to indicate the prefix that, or you have to use a prefix to indicate how many of each atom you have. So there are prefixes that will have these posted on Blackboard for you. So I'll just go through a few now. So 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, and there's more, and again, these will be on the Blackboard, so you can use those. Now, if the first element only has 1 present, so here, this phosphorus is only one of them, you don't have to give that a prefix. But that's the only time when you don't have to use a prefix in a covalent compound, is when the first element only has 1 atom present. If the first element has more than 1, you do have to give it, and you always have to give one for the second, even if there's only 1. So there's 5 chlorines, so we have to give it a penta prefix. So now we have phosphorus, pentachloride, and that is your answer. Let's do another example. So let's say we have P4O10. So now both elements have more than 1 atom present. Right? So we're going to have to give a prefix for both of them. So the prefix for 4 is tetra. So we're going to say tetra phosphorus. Now the prefix for 10 is deca. But if the name of your element begins with a vowel, like oxygen does, then for all of these prefixes, except for di and tri, you can drop the last, so not di and tri, but you can drop the last vowel. So instead of saying deca oxide, we would just say decoxide. So dec, and then again the root of the second element with an IDE suffix. Tetraphosphorus decoxide. And let's do one more. CO. So now there's 1 of each atom, or of each element type. So again, we still don't have to give a prefix for the first one, so we can just say carbon. But we do have to use that mono prefix for the second element. But again, since oxygen starts with a vowel, we drop this last O, and we just say monoxide. Alright? And that's for covalent compounds. Now, let me move on to acids. So there's 2 different types of acids, as I alluded to, and they have different naming schemes. So binary acids, basically what you want to do to identify those is know that they don't have oxygen. Whereas oxy acids, I'm sure you could probably piece together at this point now, do have oxygen. So do have oxygen present. Right? So I'm going to start with binary acids because they're a little simpler when naming. So for binary acids, we'll use HCl as an example. I'm sure you've seen that molecule before. So you can start by taking whatever is bonded to the hydrogen. Right? So in this case it's chlorine, and you just use the root of that. So we say chlor. Now you need to give it a hydro prefix. Right? So hydrochlor, and give it an IC ending, and then you just put the word acid. Hydrochloric acid. Let's do one more. Let's go with HBr. So again, you see neither of these have oxygen present within the molecule. So this is bromine, and the root of that is just brome. So we're basically just going to substitute that in for chlor, and otherwise have the exact same thing. So hydrobromic acid. Right? And that's it for binary acids. And last are oxyacids. Alright. So for oxyacids, let's go, I'll do two simultaneously, and you'll see why. HNO3 and HNO2. Okay, so one thing you'll notice that for oxyacids, you're always going to have hydrogen bonded to a polyatomic, and it's always going to be one of your common polyatomics that you'll once again need to know. So this time you don't give it any kind of prefix. You just start with the root of your polyatomic. So this is nitrate, and for what it's worth, NO2 minus is nitrite. So they both have the same root. NITR, NITR. Now, remember I said just now that NO3 minus in its polyatomic form is nitrate with an ATE suffix, and NO2 minus in its polyatomic form is nitrite with an ITE suffix. So if you have a polyatomic, so if you're forming an acid with a polyatomic that has an ATE ending, you give its acidic form an IC ending. And then of course you just write the word acid, so nitric acid. If, however, let's say we have if we have a polyatomic that has an ITE ending, like in its polyatomic form, then in its acidic form you give it an OUS ending, so nitrous acid. So again, no hydro prefix for oxyacids, and if the polyatomic form has an ATE suffix, it becomes IC. If the polyatomic has an ITE suffix, it becomes OUS. And you won't have to worry about any acids with different suffixes for their polyatomics. And that's it.